Hello, my name is Alexandra DeCesare. I am a senior undergraduate majoring in physics, and our project is on drone-based quantum communication. It's the year 2020, and the likelihood of devastating security breaches is ever growing as we approach the coming age of quantum computing. Simply put, our personal and homeland security are at risk. As you see in the image on the left, conventional computing is based on a simple binary concept where information is translated into a sequence of zeros or ones. In quantum computing, information can be in a state of 0 and 1 simultaneously, allowing them to work on millions of computations in parallel. Taking 1 second to process what would take a classical computer 10,000 years. The current security systems are secured with these classically based encryption keys. The problem with this is that anyone can intercept the radio signal, and if they have the encryption key, then the transmission is no longer secure. This means not only could someone listen in, but there would also be no way of knowing that someone is in your network. The only way to combat the inevitable is to change the way we secure our information, and that is by utilizing quantum characteristics. In 1984, Charles Bonnet and Gil Brassard developed a theoretical security protocol where bits of information are encoded in one of 4 polarization states of light, as you see in the left image. For our design, we used horizontal, vertical, right and left circular. In simple terms, we have 2 parties conventionally known as Alice and Bob, if you see on the right, who send, encode, receive, and decode bits of information until an encryption key is generated for later use to securely transmit information. Using quantum characteristics, we can tell if there is an eavesdropper, known as Eve, and thus the key will be thrown out and the encryption key generation process will start over. This helps us beat classical and even quantum intrusion on our network. By using a laser as a source for Alice and a series of optical elements to act as Bob, we have taken this BB84 protocol and turned it into a realistic, practical solution. What started out as a 3D CAD design has now come to life in our optics lab. With this device in an ideal setting, we are able to send information to Bob with percent error polarization state between 5 and 7%, and we see that the theoretical max error rate is actually just less than 11%, so this was a successful proof of concept. Now, people are already using quantum communication using satellite-to-ground methods of communication. However, this poses some challenges such as loss of information due to turbulence, fog, and other weather-related events, as well as loss of signal due to geographical restrictions. Satellites are expensive and not accessible to every company. So the solution: to overcome this, we are taking our communication systems to the next level by putting them on drones. This will allow transmission stations to be feasible for companies to invest in compared to satellites. It will allow for such systems to be mobile, allowing military personnel to communicate securely in non-ideal situations where satellite or radio communication are disrupted or at risk for hacks. It also allows transmission to be mostly wireless and is entirely more secure than classical encryption. As we see on the right, we have what is called a mobile aerial network. These mobile quantum networks can be employed in a wide variety of applications. Within the military aspect, the network can connect mobile ground forces with the forward operating base and local air support. Mountains will no longer be an issue for signal loss, and retransition sites will no longer be needed, freeing up more soldiers for battlefield support. Outside of the military, this application can be used to securely connect various types of businesses with both internal and external data transfer, ensuring the security of personal information. For this to be achieved, we need to create the position, acquisition, and pointing system. For information to be sent over drones must be able to link together and remain precisely aligned for the duration of transmission and key generation. This means using GPS, lasers, and complex programming to perform acquisition, pointing, and tracking to ensure the signal laser will be precisely entering into Bob's receiving and decoding optics. We have recently hit a huge milestone where we have a system tracking the location of where the receiving optics would be and works to stay in that center. We see the laser, which would be from the transmitting station, trying to find the screen of the receiving drone. When it locks on the center of the screen, it lets both drones know that they are locked and precisely lined up so they can securely transmit information with the least amount of loss and error. Our research is currently funded by 2 continued investors, L3Harris and the Air Force Research Laboratory. We even have 1 student who started a company known as QC Swarm. Future work on our project includes integration, bringing the receiving optics of Bob and the PAT system onto the bench for testing, also integrating onto the drone for in-flight testing, polishing of our system into a marketable product, and then finally reaching out to investors, which would be military, defense contractors, banks, for investment opportunities, and continuing to grow the QC Swarm company. Funding for this project was made possible through WAVE at Florida Atlantic University. Thank you.